Polar form of complex numbers. Before you work through this video, it's very good idea you know the standard form of complex numbers. If necessary, you should refer to this video which covers this topic. Thanks for watching this video and don't forget to like, subscribe to the channel and activate the notifications. It's very important to the continuity of this channel. You should remember that the real numbers can be described geometrically by the position they occupy on a one-dimensional number line, and any point can be located in the Cartesian plane using their coordinates x and y. Consider the complex number z equals a plus b times I. A complex number has two components, a real part and an imaginary part. This suggests that we can think of this complex number as a point in the plane and rewrite it as the other pair of numbers, a, b. Just as every real number corresponds to a point on the real number line, every complex number corresponds to a point in the plane. This plane is called the Argand diagram or complex plane. The complex plane looks like a standard two-dimensional Cartesian plane, except that real numbers are represented on the x-axis and imaginary numbers on the y-axis. The x-axis is called the real axis, since the points on it represent real numbers. The y-axis is called the imaginary axis, since the points on it represent purely imaginary numbers. To graph the complex number a plus bi, we plot the other pair of numbers ab in this plane, as we did before with points in the Cartesian plane. Represent each of the following complex numbers on an Argand diagram. To plot the complex number z1, start at the origin, move 2 units to the right, and then move 3 units up. To plot the complex number z2, start at the origin, move 3 units to the right and then move 2 units down. To plot the complex number z3, start at the origin, move 2 units to the left and then move 1 unit up. To plot the complex number z4, start at the origin, move 4 units to the left and then move 3 units down. We have just seen how to represent the complex number z in the complex plane. We can think of this complex number as the vector that starts at the origin and ends at the point z. The distance of point z from the origin is called the modulus or absolute value of z and is written as follows. We can determine the absolute value of z by using Pythagoras' theorem. The argument of a complex number is a measure of the angle which makes with the positive real axis and is denoted as follows. By using the basic trigonometric ratios, we can find the argument theta. We can rewrite the coordinates a and b in terms of the argument theta as follows. The complex number z in standard form is written as z equals a plus bi. If we replace a with r times cosine of theta and b with r times sine of theta, we can rewrite the complex number z in terms of the modulus and the argument theta. If we now factor an r out, we arrive at the polar form of the complex number. Let's summarize all of this. Pay attention. Express the following complex numbers in polar form. We need to determine the value for r, the modulus, and the value for theta, the argument. Step 1. Find the modulus of complex number z1. The real part is square root of 3, and the imaginary part is 1. Step 2. Find the argument of complex number z1. To find the argument, it's advisable to draw a diagram. We plot the complex number by moving square root of 3 units to the right on the real axis and 1 unit up parallel to the imaginary axis. From the diagram, we can see the complex number lies in the first quadrant, and hence the argument must be an acute angle. If the tangent of theta is square root of 3 divided by 3, so the argument is pi divided by 6 radians. Step 3. We use the values of r and the argument to write the complex number z1 in polar form. We proceed as we did before. Step 1. Find the modulus of complex number z2. The real part is minus 2 and the imaginary part is 2 times the square root of 3. Step 2. Find the argument of complex number z2. From the diagram, it is clear that the complex number lies in the second quadrant. If the tangent of theta is minus the square root of 3, so the argument is 2 times pi divided by 3 radians. Step 3. We use the values of r and the argument to write the complex number z2 in polar form. Step 1. Find the modulus of complex number z3. The real part is minus 2 and the imaginary part is minus 2. Step 2. Find the argument of complex number z3. From the diagram, it's clear that the complex number lies in the third quadrant. If the tangent of theta is 1, so the argument is 5 pi divided by 4 radians. Step 3. We use the values of r and the argument to write the complex number z3 in polar form.